Alright, welcome back. Today we're going to talk about isometric and oblique pictorials. Two types of pictorials that you need to know the difference of, and you need to know how to draw them. What we're doing is taking a 2D illustration and making it look like a 3D object. We're going to show three faces of that object view. So we've got top, we got front side, and then we've got a right side view that's there. We could change them and rotate them around. We'll look at that. So we're going to look at isometric. We're going to go oblique. We're going to look at perspective. So looking at just this slide itself, you should be able to see a difference between the isometric and the rest of them. What is that? Well, the isometric is turned back at an angle. You've got parallel, parallel. All the lines are parallel. Nothing converges, but that side here is facing off in this direction, right side's there. What's the difference between the rest of these three? You've got front face, it's flat. Nothing's going back in time. This one is drawn in flat. If this is a 2D shape, nothing going back there and working through. What do we got? Oblique, oblique, parallel, parallel, parallel. Everything going back, everything up and down. All of our horizontal and vertical lines are parallel to each other. Perspective, it's hard to notice on this picture, but these perspective ones, these are going back. They're going to converge at a point. These guys are going back. They'll converge. We'll talk about perspective later. So the oblique. The oblique pictorial starts with a straight front-on view of one of the object's faces. So we try to select that front face that's here. So we got 1, 2, 3. We got 1, 2, 3. There's the three different faces off of that front, and then it goes back a little bit at a 45-degree angle, so cutting right between those squares on that orthographic paper when we try to draw stuff. We got oblique pictorials. There are two types, a cavalier and a cabinet. The oblique cavalier has a type of depth, and a cabinet has a different type. And we'll talk about those two on the next slide that's here. The oblique cavalier appears to be deeper than it actually is. So when I try to remember this, I think cavalier is the basketball court, so it's really deep, and it's there. So it's got a deep run from one basket to the other. It's like a basketball court from front to back. The oblique cabinet is a more realistic view. When I think of a cabinet, I don't want my cabinet to be really deep because I want to be able to reach the stuff that's in the back there. So my cabinet looks distorted the way it is, but more of an actual depth that's being created there. So if I went 2 by 2 here, I would try to estimate 2 going back as I was trying to draw that object itself. Oblique pictorials. Following slides, I'll go through them quick of how to actually go and create one. If you want to follow along a little bit slower, you can look and go back to the notes itself and follow along with yourself there. What they do is they take that front face, this L shape, and they draw a box with the overall height and the overall width. They give it depth to it, so it's 1 cube back, so they went about 2 that's back there. Your Pythagorean theorem will help figure that out. Draw that front face, draw lines going back, drawing those object lines. What are these red lines? These red lines are your construction lines. We learned that about earlier this week. Object lines being thickness. Draw some more construction lines to help connect and draw some right angles that are in there. Drop that back and you've got there. There's your oblique cavalier. A little bit more depth than your cabinet. Oblique. Parallel, 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 parallel. Everything is parallel going back and front and left and right for us. You can do a little bit of tonal shading to help enhance that 3D object itself, give it a little more realistic. You got your general oblique. General oblique represents the actual size. We try to stick with this front face facing us and then going back, but you can draw it at any angle for it. Oblique, different ones, interlocking pavement. Nice little drawing of that. Front face is facing us, everything going back is parallel. You've got your guitar that's here. Front face is flat facing us and then going back into space, giving a little bit of depth. Isometric. Isometric means everything is equal measurement. Your iso triangle, your 30 or 60 60 60, your isometric triangle, all those angles and sides are congruent. Same thing here with our drawings. Everything's going 30 degrees, 120 to be able to measure off and work with those. We have isometric paper, so anytime you have to do an isometric pictorial, make sure you grab some isometric paper. We have 3 different measurements. We have width, height, and depth. That'll be big for us as we go and we do our orthographic projections on these, and we do the top, front, and the right side drawings. Front has width and height. Top, width and depth. Right side, height and depth. That is there. So this is the front, and it's going back in that depth with us. Different isometric view we're going to use in this class is the top, front, right. You can look at something as top, left, front, but we're going to use this one inside of this class. Top view, front view, right view. Width, height, depth, height, width, depth. That's there. How do you select that front view? You want most natural position. If you set it down, it doesn't look like it's going to topple or fall over. It shows the best shape and characteristics of it. So we'll go through some examples in class. We'll hold some objects, try to pick out that best one. That front face should normally have the longest dimension to it, fewest hidden lines, so nothing that we can't see. We want to try to see as much as we can when we're looking at that. And that most stable goes back to that most natural. It's sitting upright. It looks like it could be sturdy. It's nice and strong as it's holding itself together. So they get this little like slide type example there. And they think, okay, why is this the best front view of looking at this bottom corner, looking at it this way? Well, it's got the longest dimension. That width is the longest dimension from left to right for it. Best description of the shape, because if you were to look from this back side here, you wouldn't see this indentation. We would have maybe a hidden line that represents that edge, so we don't have any of those. This one right here, natural position, if we tried to stand it up or anything else like that, it wouldn't just be laying flat. It would look kind of maybe at an angle, so it's kind of natural for it. So when we draw one, we take that sheet of paper, we can rotate it and pull it around and kind of see which direction it's looking at. So if we went and flipped this guy over, we don't know what's going on there. We've got a slant, we've got that. It doesn't look and seem right. We want to try to stand it up on its own. Just not holding up for us. It's more, everything's not fitting together. So that's why this here itself is our front face and our best natural view. They're going to go through the box method to do an isometric. We're going to do some in class here, but we'll quickly go through this. If you want to go, you can go back to the notes and follow along with yourself. But again, everything's organized. It's proportional. This not accepted. There's lines on the sheet of paper following them. Isometric, you could do circles. You could do any types of shapes that are there. So they start with that, and then they give the box method. This guy is 3 up. 1, 2, 3 up. It is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And then they go and they create there. They do that little slant. We went 1, 2, 3. 1, 2, 3. And then up 1.5. So they go up 1.5 and connect those. So they do all those construction lines that are there. Create that guy in there. Get rid of the construction, make it a little less. Tonal shade, the sun's here. Where's the shade going to be? Onto that right side. Here's another example. They have all these puzzle cubes put together. It's 1, 1, 1. So they start drawing those outlines here. There's one square there that's hitting the top. There's that rectangular solid piece that's there. And that one that's on the side. Full solid. These are 2 cubes, but they come one piece on that top. Drop it back, drop it back. That Z shape, 1, 2, 3, 4. 1, 2, 3, 4. We do not see the object lines in between. It becomes one solid piece as we go and create that. Tonal shading, sun's over here. Drop that shade on the right side. Here's some examples of a nice paper clip or clothesline clip. Here's some Tupperware that's there. Nice drawing of it to dimension those. And that is our type of drawing. We will practice later on how to do some isometric and grab some paper and make sure we get better at those. Thanks.